And for those of you that don't know, make sure you write this down. Bonding. Bonds hold elements together. It's very important stuff. Okay, now, ionic bonds specifically are bonds between a positive and a negative ion. Now, you know from your labeled periodic table that some ions, some elements are positive, they have a positive charge or can, and others have a negative charge or they can. Okay? So picture an ionic bond as a bond between a positive and a negative ion. Okay? They are a formula unit and form a crystal lattice. Okay, I'm going to add a picture in here so you guys can see that. A formula unit is the lowest possible number of things in a molecule. Okay, so it's the lowest possible combination of atoms in a molecule. So know that when I say a formula unit, that ionic bonds are a formula unit, it means that the lowest possible combination of each of them is what you see when you see like magnesium oxide, something like that. Okay, and we will get into that. We'll practice it. Don't worry about it too much. Other thing you guys need to make sure you write down is that an ionic bond is usually formed between a metal and a nonmetal. Okay, make sure you write that down. Again, it's formed between a metal and a nonmetal. That's an ionic bond. And just a little piece about ions again. They are an atom or a group of atoms with a charge. Okay, we call cations positive charges and anions are negative charges. Okay, however you need to remember that. I usually remember that cats are positively charged with energy, or they're positive, like because they're so happy. I love kitties. So however you want to remember, cations are positive and anions are negative. Make sure you do remember. Now, you have on your periodic table, you have some stuff labeled such as negative and positive ions that can be formed from elements, and you have the stair step labeled and positive or metals and nonmetals. You're going to need to know this table. Now, I will give you this table, so you don't need to write all this down. But these are what we call polyions or polyatomic ions. So in other words, poly being many, ion being positive or negative charge thing. What you need to do when you get this table, you're going to be memorizing these. So what I want you guys to know about these is, I'm just going to take one and look at it. NH4 plus ammonium ion. Okay, NH is made of nitrogen and hydrogen. Okay, it's actually made of 4 hydrogens. Okay, that's what that 4 is. And the little plus indicates that it's a positive. Oops, that's terrible. Indicates that it's a +1 charge. Okay, if it's a +1 or a -1 charge, then it's not actually going to show the 1. Okay, so you can assume that anything that has a minus or a plus next to it is just +1 or -1. Okay, so then I'll look at the same thing here with the dichromate ion. Okay, it's made of 2 chromiums and 7 oxygens, and that whole polyion has a -2 charge. Okay, we actually write it in science. We write it as 2 negative. Okay, so go about memorizing these to the best of your ability. We're also going to talk about naming compounds. So I want you guys to be sure that you memorize the rules for naming molecular compounds, naming ionic compounds, and writing formulas for ionic compounds. Okay, you have some time. Don't panic. I don't expect you to memorize them before next class. Okay, it'll be really funny if some of you try though, but please don't. Okay, you got time. We're going to work on this in labs and such, so you have time to learn these and to memorize them. Okay, you guys want to pause to write this down, naming molecular compounds. Okay, so I will just read through them for the sake of clarity. Step 1, for naming a molecular compound, write the names of the elements in the order listed in the formula. Okay, I'm going to show you some examples. Use prefixes appropriately to indicate the number of each kind of atom. Okay, then end the name of the second element with IDE. Okay, those 3 things might not make sense right now, but we'll do some practice. Okay, so step 1 is to write the names of the elements that are present in the compound. Okay, you may remember from elements, compounds, and mixtures that, you know, if there's a little letter, then it belongs to the previous capital letter. So we only have 2 elements, 2 atoms in this compound, which are nitrogen and chlorine. Okay, there's only 1 nitrogen, so it's going to stay nitrogen. Okay, But there happen to be 3 chlorines. So we look over here at our magical little prefix thing, and so we're going to add a tri, T-R-I, to chlorine, okay? And the final step is going to be to change the name of chlorine, which is the last element in it, to chloride, okay? Just like that. So for example, number 2, we have 2 elements, P and O, so phosphorus and oxygen. So that's our first step. Second step would be labeling with prefixes how many of each there are. There happen to be 2 phosphorus elements, so we just add a diphosphorus. And oxygen, there are 3, so we again add tri. So we have diphosphorus trioxygen, but we have to label it, we have to name it correctly, so we say it's trioxide. So the name of this element, this molecular compound, is diphosphorus trioxide. Okay, so you guys will get the hang of this. The more you practice it, the more you do it. For this one, we have N2O, which is nitrogen and oxygen present. There are 2 nitrogens, so we add a di-nitrogen. And oxygen, there's only 1, so we have to name it correctly, which we add IDE to the end, so we have dinitrogen oxide. Trust me, you guys will get practice on this and will get better very quickly if you're struggling. Okay, pause here. I want to talk about the naming rules for ionic compounds. Did you write it down? Good. So, step 1 for naming ionic compounds. Name the cation, name the positive charge. Then use Roman numerals to indicate the charge if the metal is a transition metal. Okay, that's one of the metals that's in that middle part. Okay, that's only if. And then step 3, name the anion. Then you name the negative charge. Okay, let's do some examples. Okay, so for our first example, we have calcium and chlorine present in this ionic compound. Calcium is in the +2 column, so we're naming the cation first, which simply is calcium. Okay, and then chlorine, we always end stuff with an IDE, so chlorine is going to be chloride, calcium chloride, just like that. That is calcium chloride, okay? Now, unlike in molecular compounds, we don't look at the number of compound or the number of atoms there are in something. It's just, this is the formula unit that I talked about before. It's just the lowest number of each thing that will create that compound. All right, looking at number 2, we have NaBr, which is sodium, is the cation. Sodium is +1, and Br is bromine, so we're just going to call it bromide, just like that, sodium bromide. So what we're doing as we look through this is ignoring the numbers because none of these so far have been transition metals. Let's do this last example. Barium, and that's nitrogen, which we actually end by calling it nitride. So there, magically, we have barium nitride. And just a little note regarding ions. When something is an ion, we end it in IDE. So an element such as chlorine becomes chloride. Oxygen becomes oxide. Nitrogen becomes nitride. Okay? Pretty simple, but it's not intuitive, so if you're wondering what something's called, please ask. Let's look at a couple more examples. I'm going to do the 3 underlined in red, and you guys are going to do the other 3, and I'm going to check those when you show me your notes. So this first example in my second set of examples is CuCl2, which is, if we go by the rules for naming ionic compounds, Cu is copper, okay, and the second one, Cl, is chlorine. Unfortunately, I'm at home, so I'm going to have to type this out for you guys. I don't have my tablet, so hopefully you can follow along just as well. Okay, so now what we have to do is go about naming using the Roman numerals to name which copper ion we're working with, okay? And so there are a couple different ways we can go about doing this. The easiest way is to use the crisscross method, which is where we look at this, the anion, the negative charge, and we look at how many there are. Okay, there are 2. So that means copper is going to be copper 2. So we put that in parentheses in between. Oops. Sulfur. Okay. Then we have to just rename chlorine as chloride. Okay. So CuCl2 is copper 2 chloride. So moving along in the examples, we have CuBr, which, if we're following along in the correct order of naming things, the cation, the positive charge, Cu, is copper. And so copper, we know, if we look at the periodic table, I don't have it right there, but copper is right in the middle in those transition elements. So we know that we have to name it with a Roman numeral. So figuring that out is as easy as looking at crisscross. So you guys will see this again, the crisscross method. I'm not actually demonstrating it as the crisscross method. What I'm actually showing it as is that copper, this cation here, is going to reflect the charge of the number of atoms that are present in bromine. Okay, we're going to get some more practice on this. It might not be the easiest thing to understand via lecture, so you guys will get some practice with this. But because there's one bromine, okay, we'll put Br, bromine. Because there's one bromine, it means copper is going to be copper 1. Okay, so then if we rename this appropriately, we call it copper 1 bromide. Let's look at another one. Okay, this last one is Ca parentheses OH close parentheses 2. Okay, the first one, the cation, is calcium. Okay, calcium is not a transition metal. It's actually in the second column. It's not a transition metal. It has a +2 charge. Now we can address the anion, which is the hydroxide ion. Okay, that's a -1 charge, so I'll put OH equals hydroxide. It already has its own name, so pretty much if we're going to name this, it's called calcium hydroxide. It's a very simple one to do. Okay, this is a really important thing to remember, guys, when you're doing these, is if it's not a transition metal, you ignore the numbers. Okay, the numbers don't matter, like the little subscript 2s and 3s and whatever. They don't matter when it comes to an ionic compound that's not involving a transition metal. Now, I did these 3, so you guys need to do these other 3 as practice, okay? I'm going to check these as part of your notes when you come back, so make sure you've done these 3. And for this one in particular, note that the Roman numeral is the charge of the individual ion, okay? So just because there are 3 CRs doesn't mean that it's going to be like +6 or +12, okay? It's going to be the charge times 3, okay? So you're going by the individual charge, and that's how you name it, okay? Don't name it because there are 3, name it as though there's 1 with that kind of charge. Where we have to go next is writing formulas, okay? You just did some practice with me looking at naming compounds, so taking the formula and turning it into a name. So now we're going to look at how you go about writing a formula. So how do you name something like Cr3N2? How do you know that it's Cr3N2 and not Cr25N23? Okay. Make sure you take a second to pause and write these down. You're going to need to memorize these. You're going to get a lot of practice and you're going to get really good at it. Just take a second to write them down. Hopefully you wrote them down. I'm going to read them again for you so that you can hear them. So, formula writing rules. And this is for ionic compounds. Make sure you write down that this is for ionic compounds. Okay, number 1, write the cation with its charge. Okay, so you have the information in the periodic table that you guys wrote down that row 1 is +1 and row 2 is +2 and so on. So you write the cation as you know it with its charge. Then part 2, you write the anion with its charge. Okay, that's going to be a negative, a non-metal with a negative charge. Then you determine the ratio of cations to anions that add up to a charge of 0. So an ionic compound is something that forms in a way that the compound will equal 0. It'll be a net of 0. It will be neutral. Okay, so that's what we're going to work on a lot in class after this lecture. Okay, and step 4, use parentheses for any polyions, which are from that table.
that you guys have to memorize, such as, I don't have any off the top of my head. Hydroxide is one that you don't have to memorize, but it's the OH that we worked with. Okay, I'm going to type out some examples for you. It's not going to be pretty, as, again, I don't really have my, well, I definitely don't have my tablet here with me, so I'm just going to type, trying to draw, it's just bad. Anyway, let's do some examples. So we have a name. We have strontium iodide. So strontium, if we follow the directions, the first part is the cation, okay, and that's strontium, which is Sr. And I'm going to look on my periodic table that I happen to have over here, and I know that it's +2. So I'm going to put it as 2+, okay? Not super neat, as I said, but it's Sr2+, okay? And iodide, looking on my little periodic table over here, iodide has a -1 charge, so I negative. So now we've got to do this in a way that these add up to a neutral 0 charge, okay? So I'm thinking that if I is 1 negative, if I add another I, then I have 2 negatives and 2 positives, so my strontium iodide, the formula name is going to be Sri2. And I'll even make it pretty. Okay, let's look at the next one, lithium nitride. Looking at my little periodic table over here, starting with the cation lithium. Lithium has a +1 charge. Okay, I'll do it like this. Lithium has a +1 charge. Nitride, or nitrogen, actually has a -3. So N has a -3 charge. We'll do it like this. Okay, so we've got a little problem here. We've got a +1 and a -3. Okay, so neutralizing that, I'm going to say that there are probably, I'm going to do it fancy like this. Let's say there's probably 3 of these. Okay, so then just write the formula like that, Li3, this is going to be pretty, N. Just like that. That is the formula for lithium nitride, Li3N. Moving on, barium oxide. Barium is our cation. It's on the left of the periodic table. It's a metal. It has a +2 charge, 2+. And oxygen, oxide, happens to have a -2 charge. So that's actually really simple. I'll write it like this. It has a -2 charge, so that's actually a really easy one to name, BaO. It's an equal ratio of 1 to 1. What about calcium sulfide? We worked with calcium a little bit earlier, so you may remember that calcium is a 2+. Sulfide, or sulfur, is S, and it, on my little periodic table over here, oops, it has a -2. Which, again, makes it really easy for us. Calcium sulfide is an equal 1 to 1 ratio of calcium and sulfur, CaS. And the last one. Are you guys getting the hang of this yet? Let's look at calcium, which we just did. We know that it's 2+ based on the previous question. And phosphide. Phosphorus. Oh, look at you guys know what it is? Yeah, on my periodic table it says it's a 3- charge. Okay, so this is going to be a little different to name. I'm going to give myself a little more space. So if we use a crisscross method, which you guys are going to practice this probably next week, not this week, but next week, there's the crisscross method where we look at the charges on the cation and the charges on, the charges on the cation and the charges on the anion, and we crisscross them. So we just switch them and we say that, well, if calcium is +2 and phosphorus is -3, then the way it's going to work is that they'll have to have the opposite number of each other. So in other words, Ca will be 3 and phosphorus will be 2. Okay, I'll even make it look pretty. We did it before. Okay, so that's using the crisscross method, that the positive charge on one side and the negative charge on the other side flip-flop for each other. Okay, you'll see that again. And I'll also show you guys the other way to do it really quickly, would be to say, what is the common denominator? Okay, I'll do a little multiplication here. Common denominator of these two is going to be 6, right? So what do we multiply 2 by to get 6? 3. And well, what do we multiply 3 to get? 6. 2. Okay? We end up with the same thing, Ca3p2. Okay, and you guys can do this whichever way you feel more comfortable with and that you get the most confidence out of as far as doing ionic compound formula naming, okay, and formula writing rules. And I should probably stop now because, oh, never mind, she's asleep. Next class, we'll be practicing this stuff and we'll be doing a pre-lab for the copper cycle. It involves very dangerous, very strong acids and bases, so please, this will be a lab where you have to wear your goggles. I've been pretty lax, but this will be a lab where you have to wear your goggles. I'll remind you many, many times. And I will see you next class.